Okay, so in this video, I need to wrap up a few loose ends regarding public inheritance and the special member functions. So, there are several special member functions that all classes have in some form. A constructor, a default constructor, a destructor, a copy constructor, and an assignment operator. And so an important question to ask is, what happens with these on public inheritance? Well, the short answer is that these special member functions from the base class are not inherited by the derived class, which means we need to provide our own, or the compiler will need to make them for us. Now, just like for the classes we've seen up until now, if we don't provide these special member functions, the compiler generates them for us. And that's still true. For derived classes, the compiler will help us and generate them for us. But we still need to adhere to the rule of 0 and rule of 3 requirements. If we need a copy constructor for some reason, then we need to implement the other, all 3 of the special member functions. And we can't expect that those just inherit from our base class. Now, when we say it's not inherited, what do we really mean by that? Well, all we're really saying is that a derived class needs its own versions of those functions, right? Even if the base class has a copy constructor, we can't just pretend like that's the derived class's copy constructor, because the derived class may have additional new members that it needs to handle. And so just the general rule is the special functions, the special member functions in a base class can't be imported and used directly in a derived class as its own special member functions. So we need to provide new ones. Now we can still use these special member functions in the base class at certain times. For example, when we construct an object, a derived object, we can call the constructor for the base object. So it is inherited in that sense. It's there in the base object. We can call them and use them, but they can't serve as the special member functions for the derived object. Okay, so what do we need to do? Well, we need to understand what special constraints there are on special member functions in a derived class. And we've already talked about some of those constraints for constructors, right? So a constructor for a derived class needs to worry about how to constructing the base class object, because the base class may have private members that the derived class can't modify. And so, what we learned before is that a derived class constructor should explicitly call the base class constructor from a member initializer list. And then we know if we omit a call, the compiler will insert a default constructor call to that base class if it exists automatically for us, okay? But if it doesn't exist, we have to take some action to take care of it. So we've already seen this for constructors. We know we have to take some special action. Okay, but what about the copy constructor? Well, the copy constructor is just a special kind of constructor. And that means that the same thing we did for the other constructors, we're going to do for the copy constructor. So when we write a copy constructor, let's say we have a derived class that inherits from base. Then when we write the copy constructor for this derived class, what we're going to do, we're going to add an initializer list. And in that initializer list, we're going to call the base class copy constructor. Now, this may not immediately look like the copy constructor to you, but it is, because remember, the other object here is a base, right? Since derived inherits from base, then this other is a base, which means I can pass it into any function that wants a base. So if I call the base constructor and pass in a base object as its argument, that's asking for the copy constructor to run. So this will invoke the copy constructor on the base object. And so that's just saying that in this special case where I'm copying from one kind of derived object to another kind of derived object, the first thing I'm going to do is pretend like this other is a base object and perform a copy just on the base components using the base copy constructor. And then after I do that, I'll finish copying the other components using whatever I put into this function definition for the derived copy constructor. Okay, so that's how we deal with the copy constructor. We just need to add a base copy constructor call in its member initializer list. What about destructors? So when we delete a derived object, what will the compiler do? Well, it turns out it does a lot to help us. So it will call the derived destructor first, and then it will call the base class destructor. So actually, when we write destructors for a derived class, we don't necessarily need to think much about the base class. That's good news. And in fact, it might be tempting to explicitly call the base class destructor, but that would be wrong. You must not add the base class destructor to your derived destructor, okay? It's not allowed. The compiler does the calling of the destructor for you. Okay, so let's take a little look at this code. So I have a base class here that allocates an array, or that has a pointer, and then in its constructor, we allocate an array. And then in the base class destructor, we deallocate an array. And then in the derived class, I just inherit from base, and I don't have any new members. And then in main, I declare an object of type derived. So what's going to happen is that inside D, when I construct this D object, it'll call its constructor, which will call the base constructor, which will allocate this array. And then when main ends, this object gets deallocated, which will trigger the destructor for the derived class. And then the compiler will automatically call the destructor for the base class and delete this array. So that's pretty cool. So in this case, the array in base is going to get deallocated for us. No problem. And notice we didn't even have to do anything to this destructor. The compiler just did it for us automatically. It knew that D was being destroyed. And so it inserted both the derived destructor call and the base destructor call. If you want to verify that on your own, you can stick some print statements in these destructors, run this code, and watch what happens. Okay, but here's an example of where things don't work quite so well. Here, I made my base class really primitive. It has nothing inside of it. But the derived class that inherits from base, it has a pointer, and the derived constructor allocates the array, and the derived destructor deallocates the array. Now in my main, I do something a little bit sneaky. And I allocate my new derived object on the heap. And by the principles of public inheritance, I store that pointer that I get back in a base pointer. Okay, rather than derived pointer, I store it in a base pointer. Perfectly fine. I'm allowed to do that. But then before main ends, I call delete on B, which is of type base pointer. You might see where I'm going with this. What's going to happen? What's going to happen is that when I call delete here, the compiler thinks that this is an object of type base. And so it calls the destructor on base only. And as a result, this array, the derived destructor never gets called, which means this array never gets deallocated. Well, that's not good. So array is never deallocated. This is a big problem. So I need to fix this. And the way I fix it is using polymorphism. We say that really this destructor in base should have been a virtual destructor. Now this appears to violate the rules I told you before about virtual functions. I said virtual functions have to always have the exact same name, but virtual destructors don't have to obey that. Virtual destructors have different names. It's okay. The compiler figures it out because it's a special case. So since base's destructor is now labeled virtual, everything's going to work now because when I try to delete B in main, the compiler knows, oh, B has a virtual destructor, and what I really need to do is call the destructor inside for the derived object here so that the array is properly deallocated. And so now I have now by making this base destructor virtual, I'll solve that problem. And so there's a rule of thumb we can extract from this example, and that is whenever we have a base class, we know we're going to inherit a lot from it. And especially if the classes that are going to inherit might have allocated objects on the heap, then those base classes should be virtual. Those base class destructors should be virtual. And so as a general rule, since it doesn't really hurt anything, you could just say base classes should always have virtual destructors. And so even if that destructor doesn't need to do anything, we can put a destructor here and call it virtual. Okay, and then the other special member function is the assignment operator, operator equal. So it's possible that when we use operator equal on a derived object, that the base object could have private members that need to be copied on assignment. And those would be private members that we can't see and don't have access to from the derived class. So the solution here is to call the base class operator to copy the private base class members. And that code will look something like this. So this is the standard idiom for operator equals. And again, we're assuming that derived is the name of the class I'm currently implementing and that it inherits publicly from base. And so after I check to make sure that the object that I'm assigning from isn't the same as this object, right? If they are the same, I don't want to do the assignment because they're already equal and I just quit, just return. So, once I get past this initial check, then what I do is I insert a call to operator equal on the base object. And I can do that just by saying base : operator equal other. And again, this operator equal would have expected a base object as its argument, a reference to a base. But again, other is a base. And so we can just pass it in to this operator equal. And now the operator equal on the base object will do all the copying of the members it knows about in its class. And then after it gets done, right, we return here and we finish the copying. I just put a comment here, copy derived members from other to this, since I didn't show you a full class. I don't know what code should be there, but right, whatever code should be here, whatever code is needed to finish copying the members in derived from one derived object to another, you need to copy that here. It would match the copy constructor almost verbatim. And then the last thing is we always return star this from the operator equal. Okay, so those are the special member functions, and those are kind of the techniques we need to deal with them in the case of inheritance. The last thing I want to leave you with is that the rule of 3 or 0 still applies when we're dealing with inheritance, right? So if it turns out that both our base class and inherited class follow the rule of 0, then actually we don't need to do anything. It will generate all these special member functions for us properly, and they will work properly in the case of inheritance. It will take care of copying all the private members from the base class whenever we do a copy on the derived class. So we don't have to worry about that. Okay, for rule of 3, then we are going to have to implement those functions ourselves, right? And if we have to implement the destructor and the copy constructor and the assignment operator, then we need to remember these rules that we just went through. So 1, we need to make destructors virtual. 2, we need copy constructors to invoke the base class copy constructor and its member initialization list to ensure copying of private data. And 3, the assignment operator should invoke the base class assignment operator to ensure correct assignment of base class private data.